Second.
Perfect.
Okay. Alright. You guys ever been driving around on the highway and you see a truck and some black smoke comes out of the tailpipe? It's a diesel. That's just a short answer for it. You don't see that from gas vehicles, that's only diesels. And there's a reason for that. We all live in North Idaho. Everyone's talking about engines, dirt bikes, chainsaws. You're always hearing about it, but you might not know exactly what they're talking about. So today I'm hoping to give you some information about the diesel, and hopefully you can join in on that talk. And the reason I have the credibility to do that is because I went to NIC for 2 years for diesel technology, and I'm currently working as a diesel technician in Spokane Valley. Now for diesels and gas, they have a ton of common parts, but there's a bunch of key differences in them too. And today I'll be going over the strokes of a diesel engine, the differences between gas and diesel specifically, and why diesels are used for heavy duty applications and very specific applications. Now there are a bunch of repetitive steps that make a motor run. In today's modern diesel, there's 4 repetitive steps. Now, we refer to them as 4 strokes. And the 4 strokes are the intake, compression, power stroke, and exhaust. Now these are the 4 repetitive steps of most modern motors. This is what keeps the whole motor running. The intake stroke, you have your piston right here. So your connecting rods connect to your crankshaft. It's coming down. And then you have your valves right here. This is your exhaust valve here. This is closed right here. So it's right here just means it's closed. This one's open. So air is coming in through here. And the reason air is coming in through here is because this piston right here is moving down. And there's rings right here on the piston that go all the way around, and it kind of seals off the whole chamber. So it's actually creating a vacuum effect. So it's able to draw in air. Now for a diesel, you need a thing called a turbo. Instead of drawing it, I'm just gonna write it. And what it is it's pushing air in. It's just another part that helps push air into the motor, because in a diesel engine, it's so big, it's hard to create a vacuum effect and suck in as much air as it needs to be to make power. Now after your intake stroke, it goes all the way down. It's gonna come right back up, right here. And as it's on its way up, it's compressing everything that's in there. Air and fuel is all mixed in right here, and it's compressing it up. And that's pretty much simple. It's pretty much power stroke. And power stroke is valves are still closed. And what happens is once this gets all the way up to the top, it's called top dead center. It'll get up to about here, but it'll create a big explosion because it compresses it so hard. It creates so much heat that it's called compression ignited. It just ignites. And it shoves this piston all the way back down. That's where all the power in a motor comes from, is your power stroke. All this power, all this explosion, that's what, boom, shuts it down. Now once it's down here again, it's gonna come straight back up again. Intake valve is closed, exhaust valve is open, and all it's doing is it's moving up forward and it's pushing all the exhaust out. Simple as that. Those are the 4 strokes of an engine. Pretty much every modern engine. And diesels have to have turbos. They can't be, the term is called naturally aspirated. That's a signal for it, just naturally aspirated. That just means no turbo. It means it's vacuuming it by itself and coming in there. So gases and diesel motors have the same 4 strokes, but they're a little bit different. So when you come to the compression and the power stroke, in the diesel motor, you have an injector that's gonna be situated right here. And so right around here, it's spraying fuel. It's really whenever, every motor is different. So it's whenever the computer is telling that injector to spray. Sometimes it's on the compression stroke right here. Sometimes it's really close to top dead center on the power stroke. So it's spraying fuel. That's where your fuel comes in the diesel engine. This injector right here. And then like on the power stroke, it's ignited through compression ignition. On a gas, you have what everyone I'm sure has heard is a spark plug. So they also have injectors, but then they also have a spark plug. So this spark plug is gonna spray up here. The spark plug is right here. This is what ignites a gas motor. A gas motor can't compress enough to cause that compression ignition. So it uses a spark plug. You shoot a spark down and then it creates your whole explosion and it shoots that piston down, and that's where all your power comes from. Now a turbo is not needed for a gas motor to work. You can make a lot of power with it, it helps, but it's not needed. For a diesel, it's absolutely needed if you want to make any type of power. Naturally aspirated or non-turbo diesels, there's not enough air going into the cylinder to create enough power for it to really be worth using in any application. Now, when we talk compression ignited and spark ignited, the reason compression ignited works in a diesel motor is because they're built stronger and heavier. They use harder materials and the motors are just way bigger. There's a lot of smaller diesel motors, but you know, the main ones we're talking about in heavy duty applications, they're huge, they're massive. So they can withstand this high compression ratio right here that causes it to ignite. And gas motors, the type of material they use, you would crack the cylinder walls, the head. It's just too much power. Now that we understand how they work, we can talk about what they're used for and why exactly. So to understand this, you want to understand two terms: horsepower and torque. So horsepower, so I like to think horsepower is just, you know, quickly moving, fast. Torque is different. This is what you really understand on a diesel. No one really cares about horsepower on a diesel. This is the only thing that really matters. How I think about it is the ability to move something, like an object, or to pull it, to push it. It takes a lot of power to move something heavy. You can have a lot of horsepower, but that doesn't mean you can move something heavy like rocks, trees. You need torque. Torque is what does that. And the reason diesel engines have a lot of torque is everything is engineered specifically to do that. The length of these connecting rods, the longer they are, you can get more torque on them. How your pistons are all designed, there's skirts right here, your rings, everything, your valves, everything is specifically designed to create torque. And in the event, they also creates horsepower, but the main key is definitely torque. And they actually last longer because of this. So diesel engines run at a very low RPM. They make their peak torque around 1,500 to 2,000 RPMs. Every motor is a little bit different, but that's kind of what the average is. Gas vehicles, that's like an idle. Gas vehicles, they rev up to like 8,000, 10,000 RPMs, no problem. Diesel motors, they blow up if you do that. They just can't do that. So they run at very low RPMs, which means that they can last a very long time. It's very minor wear and tear, and they're bigger, they're stronger, they last a very long time. That's why a lot of these semis, they have 500,000, 1 million miles. I think I've seen one with like 2 million miles. It's normal for them. Gas motors, I mean, people are getting new ones after they hit 150,000. You know, it's a lot on a gas motor. Now, realistically, I could go all day talking, but unfortunately, we don't have that type of time. So today, you got to hear about the strokes of an engine, the differences between gas and diesel, and the reason diesel is used in heavy duty applications and specific ones. Overall, diesel motors are a great engine with tons of capability and a lot of raw power. And today I hope you learned why that is and how they work. Thank you.
Yeah.
I'm just gonna edit